Review the concepts. 3.1. Explain the difference between the sample average, big Y bar, and the population mean. Answer. The population mean is the average in the population. The sample average, big Y bar, is the average of a sample drawn from the population. 3.2. Explain the difference between an estimator and an estimate. Provide an example of each. 3.2. An estimator is a procedure for computing an educated guess of the value of a population parameter, such as the population mean. An estimate is the number that the estimator produces in a given sample. Big Y bar is an example of an estimator. It gives a procedure. Add up all of the values of big Y in the sample and divide by n. For computing an educated guess of the value of the population mean. If a sample of size n equals 4 produces values of big Y of 100, 104, 123, and 96, then the estimate computed using the estimator, big Y bar, is 105.75. 3.3. Review the concept. 3.3. A population distribution has a mean of 10 and a variance of 16. Determine the mean and variance of big Y bar from an independently and identically distributed sample from this population for A n equals 10, B n equals 100, and C n equals 1000. Relay your answers to the law of large numbers. 3.3 answer. In all cases, the mean of big Y bar is 10. The variance of big Y bar is var of big Y over n, which yields variance of big Y equals 1.6. When n equals 10, the variance of big Y bar equals 0.16. When n equals 100, the variance of big Y bar equals 0.016. When n equals 1000. Since the variance of big Y bar converges to zero as n increases, then with probability approaching 1, big Y bar will be close to 10 as n increases. This is what the law of large numbers says. 3.4. What role does the central limit theorem play in statistical hypothesis testing? In the construction of confidence intervals. 3.4 answer. The central limit theorem plays a key role when hypotheses are tested using the sample mean. Since the sample mean is approximately normally distributed, when the sample size is large, critical values for hypothesis tests and p-values for test statistics can be computed using the normal distribution. Normal critical values are also used in the construction of confidence intervals. 3.5 Review. What is the difference between a null hypothesis and an alternative hypothesis?